This is the Retro-8 Pro film scanner main printed circuit board from Moviestuff. This is a unit that does 8mm and Super 8. I recently replaced the LED driver on this, and I was going to kind of go through some things that I decided to change on it compared to the original install. My LED driver burned out. This is the original version here, and it's mounted directly to the printed circuit board and kind of sandwiched in between that and the front panel. It's not a particularly good location because it doesn't really provide any cooling, and this particular device does get pretty hot. So what I did was just left the leads long on it and mounted it on the other side where I could put a small fan just to cool the LED driver block off. So instead of soldering this all in on this side like it originally was, I just took the leads and soldered them in from the other side, and then have the unit out back behind it where I can put a fan on it. You could also put a heat sink on this to increase cooling on it. The manufacturer actually recommends doing it on the back side, not on the label side. So if you are going to do some additional cooling with a heat sink, I would put it on this side. There's some other options that you can do that I discovered after I started looking at COB LEDs. This happens to be an inverting buck boost converter, which is very flexible. It can handle a wide range of voltage inputs and outputs and a wide range of LEDs. It drives up to 700 milliamps and will control the voltage appropriately to get to that 700 milliamps based on how much you have the potentiometer set at for driving the LEDs. When it's at max, it will put out 700 milliamps if you can get the voltage high enough. Now that's where you can do different configurations with this particular converter, where you can run it in a boost only mode or in the buck boost mode. In the original delivery of this system, it is set up to use the buck boost mode, where the LED is driven by this LED plus and minus line. Now, since it's inverting, actually the LED plus is referenced to ground, and the LED minus is actually pulled negative. So if you run this, and measure this relative to the system ground, you'll actually see a negative voltage on that LED minus line. So what you can do if you need to use a higher forward voltage requiring LED, you can run it in boost only mode. Now this only works if your LED requires more than 12 volts to supply it. For instance, if you've got a 24 or a 32 volt forward voltage LED, you can run it in boost only mode. And the way that you do that is you tie your positive line directly into the positive on the LED and only use the negative line going to the negative of the LED, and the LED positive line is basically disconnected. Now you'll see that on some of the newer Moviestuff film scanners where it uses a higher wattage LED, where this white line is basically clipped off, and there's a jumper that goes from the LED positive to this voltage in positive. So I'm going to reconfigure my system so that I can run it in either mode. So I'll be unsoldering some of these connectors and pulling them out so that I can use them directly. That's one other thing you can do. You don't necessarily need to solder. If you wanted to use it in the original mode, you don't need to solder these two lines back in. You could just take those directly out to your LED and power it from those. So this is what it looks like now. I'll show you what it looks like after I reconfigure it. And in case you're wondering, this is the LED I'm using. It's a Bridglux high CRI 5000K COB LED. It's got a very uniform lighting surface. It's got a whole bunch of elements within the COB LED, which provides a nice uniform lighting surface, and it's much, much brighter than the original quad pod LED that was in this system. This particular one, if you just wire it directly in buck boost mode, it gets saturated with the voltage, and you're limited to 600 milliamps across this LED. Now it can be driven much higher than that, so it can get a lot brighter. So that's why I'm reconfiguring mine to drive this LED in boost only mode, and I'll be able to get the full 700 milliamps through this particular LED. So this is my reconfigured version of the LED driver. As I mentioned earlier, if you wanted to leave the driver in buck boost mode, you could effectively solder this this red hot wire for the supply directly into the board, but leave these LED positive and minus lines open so that you can get a little block to screw them into instead of using the board connector. This way you're going directly from the LED driver to the LED element and not having to go through the traces on the board. It does have a minor advantage that some of the high frequency switching noise doesn't need to go across the back of the board. On the back side of the board there are some sensitive circuits that are used for the sprocket hole detection, which triggers the camera. So in order to run it in the original mode with just the buck boost, which is a little bit lower maximum voltage, it's basically 48 volts minus the supply voltage, which is 36 volts max forward voltage output, but there's a little bit of inefficiency in there, so you're probably only going to get 32. If you want to drive it higher, you want to run it in boost only mode. In that configuration, you're just going to plug the red wire in here, and the buck boost mode is just plugging the white wire into the positive for the LED, and the LED is basically going to plug into that connector there. So this is the Bridglux COB LED that I have mounted on the cooling plate, which will eventually get mounted onto the back of the unit. But instead of plugging it into the printed circuit board, I'll just plug it into this connector, and it will be driven by this FlexBlocks LED driver. Like I said, you can run it in boost only mode, which will drive this particular LED brighter. You'll get the full 700 milliamps out of it. But if you wanted to use this particular COB LED and just leave all your wiring the way it was, you can still run it in buck boost mode, but the voltage won't be quite high enough to drive it to the full 700 milliamps. You'll only get 600 milliamps out of it, so you can get a little bit more brightness running it in the boost only mode. And once again, for the boost only mode, you're going to connect the positive source directly fed into the connector to the LED. Now, one thing to remember is that this is an inverting buck boost converter, so it's essentially pulling the negative line down to a negative voltage. So you have to be really careful. It's not just a safe negative voltage that if it hits a ground somewhere, it's not going to cause an issue. It will cause an issue. That's why you want to make sure you don't have any open leads on that negative. So here's an example of the system running in the two different modes. You probably won't be able to tell the difference in brightness from the video, but there is. So this is the system powered. Switch forward. That's the buck boost mode, which gives me about 600 milliamps across the LED. And this is the boost only mode, which gives me about 700 milliamps across the LED, and still well below the rated amperage of this particular LED, so it's safe to use at this particular current. But if you wanted to run it a little bit cooler, you can run it in buck boost mode and just let it saturate at the voltage, which only allows 600 milliamps. And just a word about cooling for this particular LED. It does draw a lot more power, so it gets a lot hotter than the original quad pod that was in this unit. So you need some effective heat sinking for this. Was the original heat sink that came with the original quad pod. I had drilled out these holes here, which are why they're a little bit wider than normal, but I was measuring the temperature through the screw hole of what the original quad pod was mounted to, and I was getting, without any active cooling, about 75 to 85 degrees Celsius, which is getting pretty warm for this. If you just put a fan on the back of it, it will cool it down quite a bit. Now, the original configuration has these two sets of cooling fins. When I took it apart, there wasn't any thermal compound between the cooling fins and the structure. I definitely recommend adding thermal compound there if you're going to use this particular device for cooling, but you still need to put a fan on it to keep the temperatures down. Doing that will increase the brightness of the LED as well as the longevity of it, and you can also have the fan blowing on your LED driver, because that unit also gets pretty warm. I measured that getting up to about 60 degrees C. So you can kind of understand when it was sandwiched in behind the back of this board, that really wasn't the best for cooling, not to mention some of the EMI noise that this generates due to the transistor switching being right next to the sensitive circuits for the detection. It's probably better to keep it on the outside anyways. So just keep that in mind. You'd probably be better off coming up with a different cooling method than the original. There's some nice fin designs out there for heat sinks that I may try in the future. But for now, this seems to work as long as I put a fan on the back of it. Your mileage will probably vary, but make sure if you don't know what you're doing, get somebody who's experienced in LEDs and monitoring the temperatures to make sure that you're not getting these things too hot. Not to mention just the life of the LED, but if it's around wood structure or anything like that, you want to make sure it's protected from any kind of fire hazards. So if you don't know what you're doing, don't play with this stuff. Get a professional to do it for you. But there are a whole lot of options out there for heat sinks and different LEDs that can be driven by this particular driver. And so here it is stuffed back into the box. As you can see, the LED power is not going to the board, but rather I'm going directly to the LED driver. I'm using this in boost mode configuration, as you can see, because the white wire, the LED positive, is disconnected. That's if you wanted to connect this to the positive, you'd be running buck boost mode, which doesn't get you as much voltage to drive all the way up to 700 milliamps with this particular configuration. You have to run it in boost only mode to get to 700 milliamps for the particular LED I have. So in that configuration, I'm basically tying the LED positive to the source voltage that also goes into the LED driver. And just to show you that it actually works, that's maximum brightness, and that's changing the brightness with the front panel knob. So everything works fine. The only things that is connected back to the board are the ground wire and the dimming lines. The positive does go back to the board, but it's tied in with the positive to the LED, and the negative I'm just feeding directly to the LED. Again, the negative on this is an inverting buck boost LED driver, so the negative line on this is not referenced to ground. It actually goes to negative voltage. So you need to be careful with this line that it doesn't short anything, because it does get up to a negative 33 volts that if it hit ground, it could short out. Now, because this is a much more powerful LED, I do have active cooling. I'm just basically using a little 5-volt USB fan that I point towards the back, and that does a pretty decent job of cooling both the LED driver, which gets really hot, the surface here gets hot, as well as the LED. Without the cooling, the additional fan cooling, the LED heat sink does get up to above 80 degrees, and that's a little bit on the toasty side. It can come way down when you're running the fan. There's probably other better heat sinks that you could use for this particular LED, but I'm just cobbling together what I have from the old system. But I would recommend closely monitoring your temperatures to make sure the LED is within the operating specs. Because I couldn't help myself, I went ahead and changed out the heatsink and also added a fan on it. And while I was at it, since it was a little cramped inside, I decided to do something that I've been wanting to do, and that's take the camera out and move it to a top mount camera. Just get rid of the mirror and another source of optical misalignment, and also being able to clean the lens and adjust it and use different cameras if I want. This is actually the 2K camera that I've upgraded this system to. Seemed to be working pretty well.